Okay, welcome everyone. This is a video that's going to cover the Introduction to Chemistry slides. For you guys, you're going to go through and fill out the Introduction to Chemistry guided notes as we go through these slides. So please open up your student workbooks, have them with you, and be filling in them, the blanks and some of the word and the definitions as we go through this video. Just to note with these videos, I'm making them just so that you have some sort of resource to go to if you miss class. I know a lot of you are involved in sports, clubs. Maybe sometime you'll just get sick, and this is a great way for you to have the information available to you anytime you want to log into YouTube and or just open up YouTube and grab one of these videos and fill in the information. At least you can learn what we went over in class. So I think it's a great way for you to stay caught up. Just a note with these videos, they're not going to be as detailed as what we go over in class. I'm going to try and go through the videos a little bit faster. The reason for that is they're still going to be long videos, but I'm trying to keep the video length just a little bit shorter, and so they won't be as detailed as what you will get in class, but at least it gives you some example problems that we might have worked in class, and so hopefully they help, even though they're a bit more brief. Also, just a quick note with the videos, please use them as a way to get better at chemistry for yourself. If you already know a section, please skip through that section in the video and go to the part that you need help with. If you're working the problems and you get it, please feel free to go ahead. You don't need to watch the whole video if you understand it. And the opposite of that is also true. If you're just not understanding a certain concept that are learning in class, you can go to the video and rewatch it until you do understand it. Chemistry is one of those subjects that sometimes it takes 2 or 3 or 4 times, if you're like me, maybe more, to understand it. And so, rewind the video, watch it again, go over it again and again until you do understand it. So anyway, just use these videos as a way to help you. It's a great way to personalize your own education, and hopefully they end up helping you. So. All right, let's get started. The Introduction to Chemistry. So you'll notice on your Introduction to Chemistry guided notes that there's a blank after chemistry. And so you're supposed to write down the definition for chemistry, and here it is. Chemistry is the study of matter and the changes it undergoes. This is an important word. We're going to talk a lot about this year, matter. So if chemistry is the study of matter, we're going to have to understand what that is. And it's a word you've probably heard all the way, probably since 3rd grade on. And so we're really going to focus on what matter is in this first couple of chapters of chemistry. And also later on in chemistry, we'll talk about the changes that matter can undergo. All right, the atom is the basic unit of matter. We're going to spend a ton of time talking about the atom. But it is the smallest or the basic unit of matter. All matter is built up of atoms just combined together. Atoms come in different forms called elements, and they can be found on the periodic table. We'll learn a lot about the periodic table, but it's just a table that has all the collection of elements on it. And we'll talk about all the different kinds of atoms. All atoms in the universe are made from the building blocks formed in stars. And that's kind of a cool thing to think about. All the atoms on Earth, so even the atoms that make up this table or the chair that you're sitting in, even the air that you're breathing, or the atoms that make up your body itself, came from stars. And so we'll talk about the origin of all matter, but they are originating from stars, which is kind of cool. So matter and its characteristics. Matter is anything that has mass and takes up space. So like this table, it has some mass, it takes up space, it's made of matter. Even the air, though, that we breathe is made up of matter. It's made up of mass, it takes up space. So almost everything that we can see, touch, and feel is matter. The smallest unit of matter is called the atom. We'll learn more about the atom in a later chapter, in the next chapter. Mass. Let's go over a little bit about what mass is. Mass is a measurement that reflects the amount of matter an object has. So if you look at, say this pen, It's made up of matter, and it has mass. And mass is just a word that reflects how much matter is in this pen. So it's made up of a certain amount of matter. Of course, if you look at a table would have a lot more mass than, say, this pen. Okay, now let's contrast that to another word that's very important to understand is weight. Weight is a measure of the force of gravity on an object. So weight is just this force that gravity is pulling down on you. And a lot of people use mass and weight interchangeably, although they mean very different things. So we really shouldn't do that. Weight, here's an example. If we go to, say, a different planet where it doesn't have the same force of gravity on it, weight will change. And so weight can change wherever you're at in the universe, but mass, the amount of matter that makes it up, will always stay the same, no matter if you go to another planet in the universe. Mass will always change. And so that's my last point on this slide. Weight can change from place to place, but mass is constant. Again, the reason weight changes is because it's based on the force of gravity. Okay, now we're going to move into, in this introductory chapter, we're going to talk a lot about data and analyzing data and looking at numbers, because you'll be surprised at how much chemistry, how much data and numbers and math is in chemistry. And so we're going to spend a little bit of time talking about it. First thing we're going to focus on is units. There are two common systems of units. One is called the SI units. SI is short for System International. Otherwise, people call it the metric system. So I'll just refer to it as the metric system from now on. An example of metric system units are a meter, which measures amount of length, a kilogram, which measures mass, how much matter it has, and seconds is the units for time. Okay, the other common system of units, and one that we're more familiar with, is called the imperial system of units. Example of this is the foot, to measure length, a pound to measure your mass, and seconds, which measure time. In science, we're always going to be using the metric system, and this kind of puts, I think, American students at a little bit of a disadvantage, because we are always using the imperial system. When we talk about length, we'll say how many feet is it from point A to point B. But the rest of the world uses the metric system, and so for scientists to be consistent in their units, we just have adopted in science this metric system along with the rest of the world. And so maybe someday America will move to the metric system altogether, and that would be nice. But so we're going to spend a little bit of time in this video learning the metric system. Here's the metric system basics. The metric system is based on a base unit that corresponds to a certain kind of measurement. For example, the base unit for length is the meter. We're not going to talk about length in terms of feet. We'll always talk about it in terms of meters. For volume, it's the liter. And the base unit for weight, or mass, I should say, is the gram. Not pounds, it's a gram. Metric system has prefixes. A prefix plus the base unit make up the metric system. If you recall, a prefix is a word that comes at the beginning of a word. And so an example of a prefix in this example, centa would be the prefix, and the root word would be meter. So put together, this would be a centimeter. And so that's kind of how the metric system will work. It always has a prefix out front. In this case, it's centa. But there's other prefixes that we're going to have to get used to. For example, kilo. Kilo means something. We'll talk about what it means here in a second. But if you put kilo and liter together, you get a kiloliter. And that's a measurement of volume. So the metric system uses these prefixes plus the root word. And these prefixes are based on powers of 10. And that's what really makes the metric system so useful, is it's based on powers of 10, which means you just move the decimal place 1 or 2 or however many you want to move it to figure out some of the unit conversions that we'll go over. We'll make sense of it here in a second. So the three prefixes that we're going to use the most this year and throughout your time in chemistry are these prefixes. So kilo, centa, and milli. These are the three that you absolutely have to know. If you look here, let me see if I can find a better color. So kilo in this box, we got centa in this box, and milli in this box. The metric system has a lot of other units or prefixes, but the three that we're going to use the most are kilo, centa, and milli. Let me just explain this, this series of boxes here. We're going to use them. I think it's useful for us as we start using the metric system to make a series of boxes like this. It's 7 boxes across, I think, so 1, 2, 3, 4, 5, 6, 7. Yeah, and I'll show you how this series of boxes can help us use the metric system. The base unit in the metric system are the meter, liter, and gram. So we're going to see this center box right here. This is called the base unit box. And the base units in the metric system are the meter for length, the gram for mass, and the liter for volume. And so we're always going to put meter, liter, and gram in this box. Okay, I've come up, since we're not used to using the metric system, I've come up with a way for you to remember them. It's a mnemonic. A mnemonic is a way of remembering something in order. So even though we will usually only use 3 prefixes, centa, or kilo, centa, and milli, it's a good idea to remember all of the prefixes in order. And this following mnemonic will help you remember the prefixes easily. So I know it's kind of a silly saying, but that's what makes it useful. So the mnemonic that we're going to use is killer hippos die by drinking chunky milk. And here's how that's going to help us. Let me show you. Let me find a better color here. Green, okay. So killer hippos die by drinking chunky milk. If you look at the first letter of each word in this saying, that first letter is going to be the letter that we're going to put in each one of these boxes. So we'll draw 7 boxes across, and then we're going to label it. So K goes in the first box, H goes in the second box, D, and then the B is for the base unit. So I always write base in this box. And again, that's the meter, liter, and gram. Drinking is for deci. The C here is for centa. And the M is for milli. And so if you remember this mnemonic, killer hippos die by drinking chunky milk, if you just write the first letter of that saying across, you'll always have all the prefixes in the metric system. Kilo, hecto, deca, these two we won't use that much. The base, deci, again we don't use that much, but centa and milli we will. And so hopefully if you ever get stuck with conversion in the metric system, you can jot that down real fast and see how that works. Okay, metric system made easy. This is what makes the metric system so useful to us. It is very easy once you get a hang of it. So here's what it says. If you move to the left in the diagram, you move the decimal to the left. So for example, if we're here at meter and we want to go to a kilometer, so kilo, we had to move 1, 2, 3 boxes to the left. So we'd move the decimal place 3 times to the left, and you've got it. And then you would have kilometers instead of meters. And also, if you move to the right in the diagram, you move the decimal place to the right. So if we were at meters and you wanted to figure out how many millimeters that would be, you would just count over how many boxes you have to move, 1, 2, 3, and move the decimal place 3 times to the right. And that will convert it from meter to millimeter. So we're going to have a series of practice problems that I hope will help you kind of see this. So it says, using the mnemonic to remember the prefixes, draw the boxes for the metric system and answer the question below. And so I've already drawn the boxes already with the computer, but if it was you, I would draw the boxes first. There's 7 boxes across. And then just remember that mnemonic. Killer, hippos, die, and the by is for the base box, drinking chunky milk. And again, the base units are the meter, the liter, and the gram. And so I always like to include that with this box as well. That's the base units in the metric system. And so now we can answer this question, 1 meter equals how many centimeters? So right now we're in this box, okay? We're in the meter box. So it started with meters, and meters is right here. So we're in this box. We want to go to centimeters. We want to figure out how many centimeters are in 1 meter. We need to come over here to the centa box, okay? And if we start here with meters, we're going to count how many boxes we go to the right to get there. 1, 2 boxes to the right. And so what that means in the metric system is we just have to move the decimal 2 times to the right. And so we're already at 1, so I'm putting a decimal in here. And we move the decimal 2 times to the right because that's what we did down here. And so that becomes 100 centimeters. Pretty easy, right? I mean, that's what makes the metric system so useful to us. So we're going to go through a few more just to get the hang of that, but very easy. You move to the right, move the decimal to the right. If you move to the left, move the decimal to the left. Okay, let's go to practice problem number 2. In your book, you'll see it's 100 millimeters is equal to how many centimeters? Again, we'll draw our boxes, 7 across, and put in the prefixes. Killer, hippos, die, buy, drinking, chunky, milk. Okay, and right now we're starting at the milli box. So we're starting right here, milli. And we want to go to this to convert 1,000 millimeters to centimeters. How many centimeters would that be? So the centa box is right here. So all we have to do is go 1 to the left. Just 1 box to the left. So that means we need to move the decimal 1 place to the left. On 1,000, the decimal, the understood decimal place would be right here. And so we just move it 1 to the left, and now we have 100. So 1,000 millimeters is equal to 100 centimeters. Okay, practice problem number 3. This one says we have 16,093 meters is equal to how many kilometers? So again, let's go through. Killer, hippos, die, buy, drinking, chunky milk. Okay, we're in meters. Well, where's the meter box? This M stands for milli. Remember that the base units for the metric system are the meter, the liter, and the gram. And so if it's at meters, we are in this box right now. We want to go to kilometers. Kilo starts with K, so that's how we know we're going to try to go to this box. So let's count how many boxes we need to go to get to kilo. So that's 1, 2, 3 boxes. So we need to move the decimal 3 times, and we went to the left, so let's move it 3 times to the left. Again, there's an understood decimal place right here, so let's move it 3 times to the left. 1, 2, 3. And so what we're going to have is 16.093 kilometers. So 16,093 meters is equal to 16.093 kilometers. Okay, very good. Practice problem number 4. Okay, same thing. We're going to use these boxes to figure out this conversion here. We're going to go in this example from 40,000 centimeters to kilometers. So how many kilometers are in 40,000 centimeters? Killer hippos die by drinking chunky milk. Okay, we're in the centa box. That would be this one, the C. And we're trying to go to kilometers. We're going to go all the way over here. And so if we're starting at this point, and let's count how many boxes we have to move. So 1, 2, 3, 4, and 5. So 5 times. If there's an understood decimal place right here, we're going to go 1, 2, 3, 4, and 5. And so that ends up being 0.4 kilometers. So if you had 40,000 centimeters, that would be 0.4 kilometers. Very easy, right? Okay, practice problem number 5. So 4,000 meters is equal to how many kilometers? And now hopefully by now we're getting the hang of this, but let's fill in the prefixes for the metric system. Killer, hippos, die, by, drinking, chunky milk. Okay, we're in the meters box. Again, the base units for the metric system is the meter, the liter, and the gram. So whenever we're starting with one of these base units, we're starting in this box, the base unit box, and we're trying to go to kilometers. Well, kilometer starts with a K, so we're going to end up coming to this box. And that's 1, 2, 3 boxes to the left. We move it 3 times, 1, 2, and 3. So 4,000 meters is equal to 4 kilometers. Practice problem number 6 says we have 4,000 centimeters and it wants to know how many meters that will be. Killer hippos die by drinking chunky milk. You'll get so used to using the metric system that you won't have to write this out every time, but as you're beginning, it's always a good idea to write this down so you don't move the decimal in the wrong direction or you move it, the correct amount of times. And so we're at the centa box right now. The centa box is right here. We're trying to go to meters. Meters, again, is a base unit. Meter, liter, and gram always come in this box. And so we're trying to go to the base unit. So that's 1, 2 boxes to the left. Let's move the decimal place 2 times to the left. 1, 2, and that will be 40. So 4,000 centimeters, you would have 40 meters. All right. Practice problem number 7 says we have 5 meters. How many centimeters would we have? Okay, we're starting in the meter box, so let's fill this out again. Killer hippos die by drinking chunky milk. We're starting in the meter box, that's a base unit, so meter, liter, and gram always go here. So we're starting in this box. We want to go to the centimeter box. The centa prefix box is right here, so that's 1, 2 boxes to the right. That means we need to move the decimal 2 times to the right, sorry. So if 5 has an understood decimal place right here, let's move it 2 times. 1, 2 would be 500. And that would be your answer for this one. 500 centimeters. Okay, a couple more practice problems and I think we'll have the hang of it. Okay, so again, let's do the prefixes for the metric system. Killer, hippos, die by drinking chunky milk. The base unit is the meter, liter, and gram, so always remember to put that in the base unit box. Okay, for this one, we're going to start with kilo, so kilometers. We're going to start in this box, and we're trying to get how many meters that would be. Meters is in the base unit box, so let's move it 1, 2, 3 times, and we're going to the right. So let's move the decimal 3 times to the right. So 0.3, let me just rewrite it down here to make it easier to see. We're going to move it 3 times to the right. So 1, 2, and 3. So that will end up being 300 meters. And so that will be your answer for practice problem number 8. All right, practice problem number 9. This is the last practice problem for metric system conversions. Let's look at what it says. Let's try it one more time. So let's fill out the boxes. Killer, hippos, die by drinking chunky milk. Okay, this problem says 0.04 kilometers is equal to how many millimeters? So we're starting in the kilometers, the kilo prefix, and that box is right here. And we're trying to figure out how many millimeters that would have. The milli box is at the very end. So this time we're going to go all the way across. So 1, 2, 3, 4, 5, and 6 boxes to the right. So we need to, let's rewrite this. I'm going to put a bunch of zeros after this because I'm going to have to go to the right 6 times. We went to the right 6 boxes, so let's move it 6 times. So 1, 2, 3, 4, 5, and 6. And so our decimal is going to be right here. If we put in a colon here, let's see, that will be 40,000. So 40,000 millimeters. So 40,000. And that will be your answer for this last practice problem for metric system conversions. All right, so hopefully that helps you with the metric system conversions. You guys will be good to work on in your student workbook. You now have the skills to do the metric system conversion worksheet. So if you haven't already completed that, go to your student workbook and complete that worksheet now. And it gives you some more practice, and make sure that you've got this skill down, because we will be using it all year. Okay. We're going to talk about something a little bit different now. Well, actually, let's summarize the metric system. So the metric system is base units in the metric system are the meter, liter, and gram. So I always put that in this base box down here. Okay, the meter, liter, and gram. The metric system is based on powers of 10. So a centimeter is 10 times longer than a millimeter. And so each one of these boxes is 10 times, represents a unit of length or a measurement that is 10 times bigger or smaller depending on which way you go. So that's what makes the metric system so easy. We can just move the decimal. For conversions with the metric system, each step is 1 decimal place to the right or left. We've gone through that. So using the diagram below, converting to the right moves the decimal to the right, and left would move the decimal to the left. All right, here's just a chart that shows some common SI base units. We talked about length, and that's the meter. If we look through here, time is seconds. Electric current is an ampere, abbreviated with the capital A. Temperature is Kelvin. Amount of a substance is a mole. We'll talk more about that later chapters. Luminous intensity, like light, would be measured in candela. Okay, you guys now know enough to do your first assignment, which is called the Metric System Conversion Worksheet in your student workbook. So good luck. Remember, if you get stuck on a problem, you can always use this video, go back through, watch it again, at least these practice problems that we did, and hopefully that helps. Good luck.